Hello and good day, everyone. In the last video, I've shown you a program that can be used to perform decisions like determining whether a person's temperature is feverish or not after converting it from Fahrenheit to Celsius. Because we know that basically the cutoff temperature for people to have fever is 37.5. In this video, I'm going to demonstrate how the IAS program can perform repetitions or uh, programs with loops. We are going to use the same factorial program which we have been using in the analytical engine. In fact, we are going to convert the analytical engine command per command into the IAS syntax and then trace it using sample values. What you have in front of you is a worksheet containing programs. The program on the left, which is in red font, is the factorial program that we have studied in the analytical engine by Charles W. Babbage. We are going to transform it into the syntax of the IAS and demonstrate how looping is done by having a trace. So in this example, we are using the variable m1 as the next multiplier, m2 or variable 2 in the analytical engine as the partial product and M3 as the constant one which is used to deduct from the current multiplier to compute the next multiplier. So we are using variables 1, 2, and 3 in order to store these variables respectively. So in this case, our program in the IAS will start formally with 4L. So we will have our first example as jump 40 to 19, our first command in order to jump to the first valid instruction. Likewise, words 1, 2, 3 here are used to store variables, namely the next multiplier, the partial product, and the constant degree. Now remember that in the first pass, our analytical engine starts with a times L002 and L001. This is to compute the next multiplier. So to do that, first we will have to load the accumulator. Load M M2. Okay, because M that's the reverse, no? Before we do as a mul, and then we say mul m1 m1 because 1 is our uh, multiplier. So by load m2, we are setting the accumulator the value 4. This becomes 4. And when say mul m1, 4 is multiplied to the partial product which is 1. And then on 5L we have to translate the store. The store is 002. So in the IAS we have a direct equivalent which is store without a D. We'll just say store M2, in which case uh, M2 will have a value of 4. Now, the next command is a minus. But first, we have to set the accumulator to what's going to be deducted. So anyway, the accumulator is already 4. We are going to deduct it by 1. So in the analytical engine, we say minus L001, L003. In this case, we have already M1. M1 is, by the way, M1, what's M1 for? We can just translate this anyway to load M1. Then we sub M3. So M1 is 4, and we sub M3. This becomes 3 minus 1. This becomes 3. And the store 001 is converted directly, no, to store M1. So M1, which is our next multiplier, becomes 3. So we repeat the same product. We repeat the same instruction. This time we are going to check if our next multiplier has reached 1. So we are going in 7L, we are going to deduct L003. So we are going to load M3, M3, and sub M1 because LC we are deducting M3 and M1. So M3 in this case is 1. Okay. Sub M1, so 3 minus 1 becomes 2. Is that correct? Load M3 1. That's the reverse equals load minus M1. So that's negative 2. Okay. How do we do a CD12? How do we do a CD12? A CD12 will jump if the egress is negative in this case, in this particular case. But since we don't have our accumulator is positive, how do we do a jump minus? We only have a jump plus. We don't have a jump minus. If you have a jump minus, we can jump directly to 4L, which is the first pass. But we don't have a jump minus, so we'll do a jump plus. So if it's a positive, we'll temporarily jump plus 8R. This is the way how do we convert, because we don't have the same logic. So we say 20 to 39. No, I'm sorry. This is 9L. We skip one. We just skip one. This is a technique. No? 9L. It should be a 0 to 19. So that in jump R, or rather in 8R, we can say jump or L. I hope you follow, no? Because in the analytical engine, we have a jump minus, but we don't have a jump minus. We will use the jump plus by skipping one line down, and then the line in between will be used to jump to the first uh, to the head of the loop. That is a technique. You can convert a jump minus into a jump plus. So in which case, we will only jump uh, to 90 to 19, which will be the same thing, which means we are going to load M2, then we are going to mul M1, and then we are going to do a halt by doing a jump, then L, or 10 0 to 19. So I hope you follow the technique that was used. Now in this case, for example, we are going to go to a second pass. Okay, we are going to go into a second pass because the jump plus did not jump. It proceed to 8R. It proceeded to 8R, and 8R jumps it back to the head of the loop, which is 4L. Now, if it were positive already, which means 0 is already a positive number, it will just jump to the next pass. So therefore, we have to do a next pass, which is pass number 2. This time, this is pass number 2. Okay. Let us write the previous values. Okay. The previous value of the accumulator is -2. The multiplier is 3, and the partial product is 4, and the decrement is 1. These are our previous values. Okay. So now we load M2. This time we look at the IAS code, no longer the analytical engine code. Load M2. M2 is 4, so this will become 4. Mul M1, so this becomes 12. 12. And store M2. So the 12 now becomes our next partial product. And then we load M1. M1 is this is to compute the next multiplier. And then sub M3, M3 is 1, so this becomes 2. And then we store M1, which means now M1 will be our next multiplier. And then we load M3, which is our current partial product, which is 12. And then sub M1, no, load M3 is 1. Sorry, we are now trying to determine whether we are going to repeat or not. And then M1 is 2. Okay, so that equals minus M1. That's negative 1. So this negative, so the jump plus will not be executed. 8R, it will proceed to the next, which is 8R, and go sends us back to the beginning of the loop, which means that this time we are also going to have a third pass. So remember, so we did nothing here but convert the analytical engine code into the in, into the language of the uh, IAS. So this is now pass number 3. Likewise, we'll have to record our previous values. Okay, our previous values. So the accumulator is negative 1. The accumulator is negative 1. The multiplier is 2. The partial product is 12, and the decrement is 1. Next is load M2. We are going to load the next multiplier, rather the next part, the previous partial product. Load M2, so this becomes 12. And mul M1 times 2, this becomes 24. And store M2 to store our new partial product. Now, our next partial product is now 24. And then we compute the next multiplier by deducting 1 to M1. So we load M1, so this becomes 2. Sub M3, this becomes 1. Store M1, the next multiplier is a 1. And then we are going to find out if we are going to proceed or not. We are going to do that by deducting the M3 with M1, which is 1. So equals minus this. Okay. So load M3 is 1, and then M1 is 1, because we have subtracted it already. So, and what we are, since this is a jump plus now, 0 is already positive, we are going to load M2. M2, which is 24, and multiply M1, so this becomes 24, and we are going to stop. So now we have the final result, which is 24, which is also in our partial product. So this is a technique that we use by inverting our logic from a jump minus into a jump plus, mainly by adding one line. Uh, in the next video, I'm going to show you a different approach in looping called top-down approach, where we do not have to convert a jump minus into a jump plus. We are going to use the jump plus itself to perform the necessary conditional branch. Thanks for watching, and bye for now.